Okay, then in the next problem we're working with the region in the first quadrant enclosed by the graphs of y equals 4 minus x squared, y equals 3x, and the y-axis. You just have to be very careful here that you choose the correct region in the first quadrant. There are two of them. There's one that's bounded by the two curves and the x-axis, and the other bounded by the two curves and the y-axis. So we want the one that's bounded by the y-axis. And so that's going to be that region highlighted in yellow there. Just have to make sure you get the correct one. Okay, then area is going to be top minus bottom. So we're looking for the integral of the parabola, which is 4 minus x squared, minus the straight line, which is 3x. We do need to find the points of intersection. And you may see that the point of intersection is 1, 3. And that can be verified algebraically by setting the two equations equal and solving for x. And you would get something like that, showing that there are 2 points of intersection. One is to the left at x equals -4, which is kind of not on our graph there, and x equals 1. So we want the integral from 0 to 1 of 4 minus x squared minus 3x dx. And the integral of 4 is 4x. Integral of x squared is x to the third over 3. The integral of 3x is 3x squared over 2. And again, that's from 0 to 1. The whole 0 expression will 0 out. And the other will just be 4 minus 1/3 minus 3/2, which comes out to be 13/6. Okay, and we'll go on to the volume part. We're going to take this as we did in the previous problems, and we're going to revolve this then around the x-axis. Revolving around the x-axis, we're once again going to get a washers problem, and that would look something like that. And we're going to again, washers is pi capital R squared minus pi little r squared, and we're going to sum that up from 0 to 1. So we take out the pi, we have integral from 0 to 1, and that is pi capital R squared, which is the parabola of 4 minus x squared. That would be quantity squared minus little r squared, which is 3x quantity squared, and dx. So for this particular one, probably we should expand out the 4 minus x squared. I don't think there's any benefit in, or will it work to do any type of u substitution in there. So the first term gets squared, and we should have 16 minus 8x squared plus x to the fourth. Then minus 9x squared dx. And simplifying a bit, I think we have negative 17x squared. And that gives us a final expression of pi times integral from 0 to 1 of x to the fourth minus 17x squared plus 16. Finding antiderivatives, x to the fourth becomes x to the fifth over 5. 17x squared becomes 17x to the third over 3. And 16 becomes 16x. And that's from 0 to 1. Again, fortunately the 0 part goes away, and we're going to have 1/5 minus 17/3 plus 16 times pi, which ends up being 158 pi over 15. Alright, so that's the second part of that. And in the next video, again, I will go through, well, this one is similar to the one that we did on the previous problem. It would be exactly the same in terms of finding, using the calculator that is. We would find our points of intersection, we would graph the two functions, and then find the difference of the two functions and the area under that curve, and then do pi times the quantity y2 squared minus y1, or however we put them in. I think you should be able to do this one on your calculator following the example of the previous problem. So I won't go ahead and make a calculator video for this one.